Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, we're going to continue reviewing all the factoring techniques with which you should be familiar in order to do your best on the Armed Services Vocational Aptitude Battery, notably on the Mathematics Knowledge Subtest. Just to recap, I've talked about how to use the quadratic formula recently, and in addition, I've also discussed some factoring techniques when you're factoring quadratics that have a coefficient of 1 as well as not 1. In the video I uploaded yesterday, I talked about how to factor by grouping. And in today's video, we're going to finish the review by discussing how to factor the difference of two squares. Let me just point this out before we get started with today's video. These three topics are very common, and they have a 95% chance of appearing on the ASVAB, whereas these other two topics are really special cases of factoring, and in light of that, they have a 5% chance of appearing on the ASVAB. That said, if you're doing especially well in the ASVAB, you will see one of these two topics almost guaranteed. In case it's helpful, I'm going to include a link to this factoring guide in the description of this video. As I go through today's problems, you may want to pull it up and take a look at it. All that said, let's get started with today's video. All right, so before we get started with some practice problems, I quickly want to show you what we're talking about in terms of just equations with no real values. So again, we're factoring the difference of squares. Therefore, we're going to be looking at equations that are all in the form a squared minus b squared. And as it turns out, the difference of squares, the solution looks like this: a minus b, a plus b. And that's really all there is to factoring the difference of squares. That said, one thing that trips people up is the fact that you're given a squared and b squared in the equation, and in the solution you just have a and b not squared. Again, in case it's helpful, let me do this off to the side. Again, we want to go from a squared to just a. So to do that, you simply take the square root of a squared. This crosses out, leaving you with just a, which you can now plug right into the solution. Similarly, to go from b squared to just b, you take the square root of b squared. This crosses out, leaving you with just b. And now you can simply plug in b in this solution accordingly. Another thing that trips people up when they're factoring is the fact that you do have to be able to recognize what factoring techniques applicable when. So if you saw an equation of this form, a squared minus b squared, you would have to realize that the solution is going to look like this, and all you have to do is identify a and b and plug it in. That said, if you were given this equation, a squared plus b squared, you would have to recognize that this is now finding the sum of two squares, and as it turns out, this is a prime equation, meaning that it is not factorable. So just by changing that minus to plus, we have an equation that's prime, which means we can't factor it. Okay, so that's one thing to keep in mind. As you'll see in just a minute, you can solve all these using the quadratic formula, which, as I mentioned in that video, takes about 10 steps or more, whereas this technique takes about 5 seconds or less. So all that said, let's go ahead and get started. For these first few problems, I'm going to be writing a lot of things out to try to make these points stick. But once I get to number 3 or 4, I'll stop writing things out. Again, as we can see, this equation is the difference of squares. You have a squared minus b squared. 1 squared is just 1, so that is in fact a square there. And according to how we factor these, again, you go from a squared minus b squared to the solution a minus b, a plus b. But that said, you do have to find a way to identify a and b. So as we can see, our a squared is 9x squared, whereas our b squared is just 1. And again, we want to go from a squared to just a, and from b squared, and that's a bad 2 there, b squared to just b. To do that, we'll take the square root of both sides. This will cross out, leaving you at just a. And the square root of 9, we should know is 3. The square root of x squared is just x. Again, to get b by itself, we'll take the square root of both sides. Let me write that over there. This crosses out, leaving you with just b. Again, the square root of 1 is just 1. So now we have a and b, and we can plug those into the form of the solution. Again, the form of the solution is a minus b, a plus b, and again, we know what a and b are, so let's plug those in. Again, a is 3x, b is 1, so this first pair in the solution is 3x minus 1, and this second pair is going to be 3x plus 1. And just like that, it took maybe 1, 2, 3, 4 steps, and we've factored the difference of these squares. That said, on the ASVAB, instead of being asked to factor, more often than not, you're going to be told to solve. And in this case, you'll be told to more specifically solve for x. Again, you have to realize that first, you're going to have to use a factoring technique. And then second, you're going to have to, once you get done factoring, break these apart and set them equal to 0 to solve for x. So that looks like this. We would set 3x minus 1 to 0, as well as 3x plus 1 to 0, and then solve for x accordingly for each of these. So I'm going to add 1 to both sides. Negative 1 plus 1 crosses out, leaving us with 3x equals 0 plus 1, or just 1. Again, we're going to divide both sides by 3 to get rid of it on this side. That leaves you with x equals 1 over 3, or 1/3. Again, to solve for x in this equation, we're going to subtract 1 from both sides. That's going to cross out, leaving you with 3x equals negative 1. Again, to get x by itself, we're going to divide both sides by 3. This is going to cross out, leaving you with x equals negative 1/3. So the solution to this one, in other words, if you had to solve for x instead of just factor it, would be x equals 1/3, x equals negative 1/3. Okay, now again, as I mentioned earlier, these can be solved using the quadratic formula as well. Again, to use the quadratic formula, you're identifying your a, b, and c and plugging them into the quadratic formula. The way you do that is you look at a standard quadratic equation, ax squared plus bx plus c. You can see you have your a, b, and c right there. Then you plug those values into your quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac. And again, that's all over 2a. If we take a look at the equation we're given, we can see the a coefficient corresponds with the square value. So in this case, 9 is going to be our a. There's no b value, as you can see, because b is the coefficient of x, and there's no x here. And c is the whole number more often than not, so c is going to be negative 1. Let's plug those values in accordingly. And again, since there's no b value, we can substitute 0 in for the b value. So this becomes 0 plus or minus the square root of 0 squared minus 4. Again, a is going to be 9, as I mentioned, and c is going to be negative 1. All over 2a. Again, a is 9, so 2 times 9. Let's keep working this out. Again, since there's nothing there, we don't have to regard it. So this is going to become plus or minus the square root of 0 squared. Again, 0 squared is nothing, but we do have negative 4 times 9, which is negative 36. Negative 36 times negative 1 is going to be positive 36. So this is the square root of 36 over 2 times 9, which is 18. Okay, so as we should know, the square root of 36 is simply going to be 6. So this is plus or minus 6 over 18. Again, as we did when we worked on quadratic, solving things with a quadratic formula, this plus or minus means you're going to break this apart into two solutions, namely positive 6 over 18, as well as negative 6 over 18. This you can reduce to 1/3, and then this can be reduced to negative 1/3. And as you can see, those are in fact the same solutions we came up with using factoring the difference of squares, whereas one took maybe a couple of steps, this one took about 10 or so steps. So again, it's always easier to use the factoring technique. But that said, I wanted to show you that both methods will help you solve these. So let's go ahead and move on to number 2. Again, this equation, as you can see, is given of the form a squared minus b squared, which is the difference of two squares. That said, in order to solve this one, which is going to look like this, a minus b, a plus b, we do need to figure out what a and b are, not a squared and b squared, but a squared, as we can see, is 4n squared, whereas b squared is 49. Again, to go from a squared to just a, we're going to take the square root of both sides. This is going to cross out, leaving you with just a. The square root of 4 is 2. The square root of n squared is just n. And again, we want to go from b squared to just b. So we're going to take the square root of both sides. This is going to cross out, leaving you with just b. Square root of 49 is 7. Now we have a and b, which we can plug into a minus b, a plus b. Again, a is 2n, so this becomes 2n minus b is 7. Again, a is 2n, so we'll plug that in for a, plus b, b is 7. And just like that, using by factoring the difference of these squares, we were able to solve this one. Again, on the ASVAB, it might say solve for n instead of just factoring, in which case you have to know, again, that you can break these apart. 2n minus 7 equals 0. 2n plus 7 equals 0. And then solve for n accordingly. To solve for n in this one, we want to get n by itself. So that's going to prompt us as our first step to add 7 to both sides. Negative 7 plus 7 crosses out, leaving us with 2n equals 0 plus 7, which is just 7. Now we're going to divide both sides by 2 to get n by itself. This says n equals 7 over 2. Again, to get n by itself in this equation, we're going to subtract 7 from both sides. This is going to cross out, leaving us with 2n equals 0 minus 7, which is negative 7. Then we're going to divide both sides by 2 to get n by itself, and this is going to equal, n is going to equal negative 7 over 2. And those are our solutions, as you can see. Again, if it said just a factor, this is where we would have stopped, but if it said solve for n, we would have to recognize that this equation is in fact the difference of two squares, and therefore its solution is going to be of the form a minus b, a plus b. As long as you identify a and b by taking the square root of a squared and b squared, you can solve this one in a matter of seconds. Okay, so let's move on to number 3. There are 6 practice problems in today's video. So if it's helpful, you may want to pause the video at this point, try to work out these 2 problems on your own, and then resume playing the video in order to see if you and I came up with the same solutions in the same way. For number 5, there is one thing you have to do before you can solve it via via factoring the difference of the squares. And for number 6, there is, I think, 2 different solutions. So just bear in mind as you do 5 and 6. That said, again, we can see number 3, which is 36k squared minus 1, is in fact the difference of squares, which looks like this, a squared minus b squared. And again, the solution is going to be a minus b, a plus b. That looks like a 6, but we'll fix it. But that said, we do have to find a way of going from a squared to just a. Again, a squared is going to be 36k squared, whereas b squared is going to be 1. And again, to go from a squared to just a, we're going to take the square root of both sides. This is going to cross out, leaving you with just a. The square root of 36 is 6. Again, the square root of k squared is just k. And again, to get b by itself, we're going to take the square root of both sides. This is going to cross out, leaving you with just b. Square root of 1 is just 1. And again, the solution for the difference of 2 squares is, again, a minus b, a plus b. We've identified a and b, so now it's just a matter of plugging those in accordingly. Again, a is 6k, so this is going to be 6k minus 1, 6k plus 1. And that's it. Again, if you wanted to solve for k, you would break these apart and set them both equal to 0. Notably, you would do 6k minus 1 equals 0, as well as 6k plus 1 equals 0. Again, you're solving for k in this case. In other words, you want to get k by itself. So you're going to add 1 to both sides. This is going to cross out, leaving you with 6. My mouse is acting up today. This is going to leave you with 6k equals 1. To get k by itself, again, we're going to divide both sides by 6 as our next step. This is going to give you k equals 1/6. If you're pretty clever, you should know that this is simply going to give you the opposite of this, notably negative 1/6. And as we get to 5 and 6, we'll start skipping a few steps. But again, to get k by itself, we're going to subtract both sides by 1. Plus 1 minus 1 is nothing. This leaves you with 6k equals negative 1. Again, divide both sides by 6 to get k by itself. This leaves you with k equals negative 1/6. And again, if on the ASVAB it said to factor this difference of squares, your solution would be right here. If, however, it said solve for k, you would be able to say k is equal to 1/6 and negative 1/6. Okay, so that's that one. And again, I've noticed a lot of YouTubers usually only do, math YouTubers usually only do 1 or 2 practice problems in their videos. As you'll see, number 4, 5, and 6 are all variations of factoring the difference of squares. And if I just did one problem, but you came across number 4, 5, 6, or 6 on the ASVAB, you'd be stuck. So that's why I try to give you more than just one practice problem. Again, right away, we should know that this is the difference of squares, which is of the form a squared minus b squared. So we know the solution is going to be a minus b, a plus b. That said, we have to figure out what a and b are before we can plug them in. Again, a squared corresponds, and my pen keeps acting up today. A squared corresponds to p squared, whereas b squared corresponds to 36. Again, to go from a squared to just a, we're going to take the square root of both sides. This is going to cross out, leaving you with just a. Square root of p squared, again, those squares are going to cross out, leaving you with just p. And I wrote a b there. I'm losing my mind today. Again, to go from b squared to just b, we're going to take the square root of both sides. Square root of b squared is just b, and square root of 36 is 6. Again, the solution to the difference of squares is of the form a minus b, a plus b. We've identified a and b, notably p and 6. So let's plug those in accordingly. Again, we're going to have p minus 6 and p plus 6. Again, if on the ASVAB it said solve for p, you should realize that 1, this is the difference of squares, so you can either use the quadratic formula or the factoring technique to solve this one. And once you get to this point, you break these apart and set them equal to 0. So notably, you'll have negative 6 equals 0, or p minus 6 equals 0. And I am losing my mind on this problem. P minus 6 equals 0, and p plus 6 equals 0. Again, let's work on this equation on the left first. Again, to get p by itself, we're simply going to add 6 to both sides. This crosses out, leaving you with p equals 6. To get p by itself in this equation on the right, we're going to subtract 6 from both sides. Positive 6 minus 6 crosses out, leaving you with p equals negative 6. And therefore, our solution is p equals 6, p equals negative 6. Okay, so again, if you were asked to factor this, you would stop right here. But if it said solve for p, those would be your solutions. All right, 2 more to go. All right, so for number 5, you might say, well, I have the difference of 2 squares, but do you really? Again, it's a squared minus b squared. Can you take the square root of 2? You can't. Can you take the square root of 18 and get a perfect square? You can't. So as it stands, this is not the difference of 2 squares. So before we work this one out, we have to do something to make this equation be a difference of 2 squares. And it's actually easier than you think. If you factor out a 2, that leaves you with x squared minus 9. And now we do have the difference of 2 squares. Notably, we have a squared as just x squared, and we have b squared as 9. And again, the solution to the difference of squares is a minus b times a plus b. And so we have to find a way of going from a squared to just a, and similarly, we have to find a way of going from b squared to just b. It's pretty simple, as we've seen. We just take the square root of both sides. The square root of a squared is just a. The square root of x squared is just x. So a equals x. In this case, we're going to do the square root of b to get b by itself, and we're going to do that to both sides. This crosses out, leaving you with just b. Square root of 9, as we should all know, is 3. So we have our a and b identified, and now it's just a matter of plugging those into the solution, namely a minus b, a plus b. But that said, we do have this 2 hanging out here. So in this case, our solution is going to look like this. Everything times 2. Okay, so we're just going to leave that 2 hanging outside those brackets. So let's go ahead and plug things in. Again, a is x, so this is going to be x. B is 3 minus 3. This one's going to be the opposite, x plus 3. And of course, we have 2 hanging outside the brackets. So that would be the solution in this case. And instead of having 2 solutions or breaking this apart, you would do this. You would say 2 equals 0, which is not a true statement. So this isn't one of our solutions, but that's how you would set it up. You would do x minus 3 equals 0, x plus 3 equals 0. And then again, to get x by itself in this one, we're going to add 3 to both sides. This is going to cross out, leaving you with x equals 3. Subtract 3 from both sides to get x by itself in this one. This leaves you with x equals minus 3. So your two solutions for this one are x equals 3 and x equals negative 3. But that said, we had to factor out a 2 from this original equation so that we could apply, so we could factor by finding the difference of squares. Okay, so that's all we had to do for that one. Number 6 is challenging because you have to be good at finding the squares of large numbers. That said, it is of the form a squared minus b squared. In particular, we know a squared is going to be 160, or that's 96, 196 and squared. And we know our b squared is going to be 144. Again, to get a by itself, again, we want the solution to be a minus b, a plus b, not a squared. So we have to go from squared to just a. And to do that, we're going to go ahead and take the square root of both sides. This is going to cross out, giving you your a. Square root of 169. It's a good idea to know your times tables for the ASVAB from 1 through 20. Again, you should know, for example, that 15 squared is 225, 13 squared is 169, 20 squared is 400, 196 is going to be 14. The square root of 196 is going to be 14, and the square root of n squared is just n. Again, we want to get b by itself, so we're going to take the square root of both sides. It's going to cross out, leaving you with b equals the square root of 144. Which we should know is 12. So now we have our a and b. So let's plug that into the solution. This is going to be 14n minus 12, 14n plus 12. And I skipped those steps, so don't blame me. By this point in the video, you should be able to do that. And that would be our solution to this one. Okay, so that's all I have for you in this video. I hope you found it helpful. Again, this week I tried to cover all the different forms of factoring with which you have to be familiar to do well on the ASVAB, including factoring when coefficients 1, not 1, factoring by grouping, factoring the difference of squares, as well as using the quadratic formula, which can get you out of a lot of sticky situations if you, for some reason, struggle factoring. So if you enjoy the content I'm putting out, by all means, consider hitting the subscribe button. It's always nice to have new subscribers. In addition, you're more than welcome to leave some feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose. Let me say this before I cut you loose. I am going to post a video soon in which I give you ASVAB questions that are going to cover all the topics I've covered over the last 2 weeks. So at the beginning of last week, I talked about how to solve system of equations. So what I'm going to do is create a practice test in which you're given real ASVAB practice questions from all those topics jumbled up to see if you can solve them using the techniques you learned in my videos. It's kind of like a review or a knowledge check. So, and on that note, I'm going to go ahead and cut you loose. Konnichiwa.